Hi everyone. Today we'll be having our lesson on the length of an arc. Suppose that y is equal to f of x is a smooth curve over the interval from a to b. The arc length L is defined as L is equal to the integral of the square root of 1 plus y prime squared dx from a to b. This comes from cutting the curve into small strips and getting the distance. So the distance d is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. So simplifying this, it leads us to this formula. If x is equal to g of y, if this function x equal to g of y defines a function whose curves is continuous on the closed interval from c to d, then the length of the arc is equal to the square root of 1 plus dx over dy squared dy from c to d. And if x and y are in terms of the parameter t, and dx over dt and dy over dt are continuous on the interval from t1 to t2, then the length is given by the square root of dx over dt squared plus dy over dt squared with respect to t from t1 to t2. If the equation of the curve is r equal to f theta in polar coordinates, and the curve is continuous on the interval from theta 1 to theta 2, then the length is the integral of the square root of r squared plus dr over d theta squared from theta 1 to theta 2. Let's have an example. Find the length of the curve y equal to ln secant x from x equal to 0 to x equal to pi over 3. For this problem, we will be needing the formula. So the formula for the length of the arc is equal to the integral from a to b square root of 1 plus y prime squared dx. So since we are given with y equal to ln secant x, we differentiate y equal to ln secant x. And that would be 1 over secant x times the derivative of secant x is secant x tangent x. So we can cancel out secant x. So thus the derivative of ln secant x is nothing but tangent x. So again, your y prime is equal to 1 over secant x, and then we multiply it by secant x tangent x. So the integral is tangent x. We plug that into the formula. So integral of the square root of 1 plus y prime squared from a to b dx. So that would be the integral of 1 plus y prime is tangent x. So we have tangent squared x dx from 0 to pi over 3. But take note that secant squared x is equal to 1 plus tangent squared x. So therefore, we have the square root of 1 plus tangent squared x is square root of secant squared x dx. And thus we have the integral of secant x dx from 0 to pi over 3. Integrating secant, we will be having ln of secant x plus tangent x from 0 to pi over 3. Plugging in pi over 3 for the upper limit and 0 for the lower limit, we will be having ln of secant of pi over 3 is 2 and tangent of pi over 3 is square root of 3. So, substituting the lower limit, it would be ln of secant 0 plus tangent 0. Secant 0 is 1 and ln 1 would be 0. And thus, we have the length equal to ln of 2 plus square root of 3. So again, it would just be ln of secant pi over 3 plus tangent of pi over 3. You may use your calculator for this. And then minus ln of secant 0 plus tangent 0. Tangent 0 is 0, secant 0 is 1. And ln 1 is 0. So that's why the lower limit would be cancelled out. So the arc length is ln of 2 plus square root of 3. Now let's have the length of the curve x is equal to y raised to 3 over 2 from y equal to 0 to y equal to 5. So we are given with x as a function of y. So we're going to use the second formula for the arc length. But first, in order to plug that into that formula, we need to find dx over dy. So that would be 3 over 2 y raised to 3 over 2 minus 1. So 3 over 2 times y raised to 1 half. We are going to square this, so it would be 9 over 4 y. So we're going to integrate from 0 to 5 the square root of 1 plus 3 over 2y raised to 1 half squared dy. Thus, we have the square root of 1 plus 9 over 4y dy to be integrated from 0 to 5. So, we factor out 1/4 and put it outside the radical, so it would be square root of 1/4, which would be 1 half. Integrating 4 plus 9y, square root of 4 plus 9y dy, so that would be 4 plus 9y raised to 1 half dy. We need a correction factor of 9. So this would be equal to 1 half the integral from 0 to 5 of 4 plus 9y. So we need 9 dy. So we have a neutralizing factor of 9 raised to 1 half. So that would now be 4 plus 9y raised to 3 over 2 over 3 over 2. So we have 1 half times 1 over 9 times 1 over 3 over 2. So that's 2/3. 4 plus 9y raised to 3 over 2. Plugging in 5. So upper limit minus lower limit. So we have 1 over 27. 4 plus 45 minus, for the lower limit, it is not automatically 0. So we have 1 over 27, 4 plus 9 times 0, raised to 3 over 2. So both are raised to 3 over 2. So this would be giving us 1 over 27, 49 raised to 3 over 2 minus 1 over 27, 4 raised to 3 over 2. So this would be 7 cubed over 27 minus 4, square root of 4 is 2. 2 cube is 8 over 27. So this is 343 minus 8 all over 27. And that would give us 335 over 27 units. Find the length of an arc of a cycloid given in parametric form by the equations x is equal to t minus sine t and y equal to 1 minus cosine t, where t is from 0 to 2 pi. So we have a formula for the arc length in parametric form. So we are given with x equal to t minus sine t and y equal to 1 minus cosine t. Its corresponding derivative would be 1 minus derivative of sine is cosine. So 1 minus cosine t, and the derivative of 1 is 0. The derivative of negative cosine t is positive sine t. We plug it into the formula. L is equal to the square root of dx over dt squared plus dy over dt squared from t1 to t2. So we integrate from 0 to 2 pi. The square root of 1 minus cosine t squared plus sine t squared. So this would give us, so expanding the binomial, we will be having 1 minus 2 cosine t plus cosine squared t plus sine squared t. Now take note that cosine squared t plus sine squared t is equal to 1. So we will be having 1 plus 1 equal to 2. So we have 2 minus 2 cosine t, factoring out 2. So we have 2 times 1 minus cosine t dt from 0 to 2 pi. We apply the half angle identity for this one. So we have 2 times 1 minus cosine t is equal to so we apply the identity sine squared t is equal to 1 half of 1 minus cosine 2t. So this would now be 2 sine squared t equal to 1 minus cosine 2t. But since the angle is just t, so we take the half of that. So it would be so 2 times 2 would be 4. 4 sine squared t over 2. And taking the square root of that, it would be 2 sine t over 2. So 2 times sine t dt from 0 to 2 pi. We apply correction factor and neutralizing factor. So we need 1 half here and multiply it by 2. So we would be having there should be 2 here. So the integral of sine t over 2 times 1 half dt would be 2 negative cosine t over 2 from 0 to 2 pi. So take note that this should now be 4. So plugging in the upper limit, so 2 pi over 2 would just be pi, and cosine pi is negative 1, and cosine 0 is negative 1. So we will be having, I think the length should be 8 units. Let me check this. Okay, so the answer is indeed 8 units. Okay, let's have additional examples. Find the length of each of the following curves. Y equal to x raised to 3 over 2 from x equal to 0 to x equal to 5. So since we are given with y equal to f of x, we're going to use the formula length is equal to the integral from a to b square root of 1 plus y prime squared dx. So our y is x raised to 3 over 2 and our dy over dx is 3 over 2 x raised to 1 half. So our dy over dx squared is 9 over 4 x. So for our formula for the length, it would be the integral from 0 to 5 of the square root of 1 plus 9 over 4 x dx. So we can let your u be equal to 1 plus we can let our u be equal to 1 plus 9 over 4x. So our du would be 9 over 4 dx. So we apply a correction factor of 9 over 4 and neutralize it with 4 over 9. With that, we have the length is 4 over 9 integral from 0 to 5 of 1 plus 9x over 4 times 9 over 4 dx. So this is raised to 1 half. So we have 4 over 9, 1 plus 9x over 4 raised to 3 over 2 over 3 over 2. This is to be evaluated from 0 to 5. So the length is equal to, so this is 8 over 27, 1 plus 9 times 5 over 4 minus 8 over 27 times 1 plus 9 times 0 over 4. So we have 8 over 27 times 1 plus 45 over 4 minus 8 over 27 times 1. So not all lower limit would become 0. So we have 8 over 27 times, so this is 49 over 4 minus 1. So here we will be having 8 times 48 over 4 times 27. So, sorry, 49 minus 4 is, sorry for that. So it would be 49 minus 4 is 45. So we have 8 times 45 over 4 times 27. So 8 over 4 is 2. So we have 90 over 27. Let's double check that. Okay, sorry. This is to be raised to 3 over 2. Let's have that correction. Let's apply that correction. So we will be having, sorry for this. So that would be 8 over 27. And then this is 49 over 4 raised to 3 over 2 minus 8 over 27 times 1 raised to 3 over 2. So that would be 8 over 27 times 7 over 2 cubed minus 8 over 27 times 1. So we can factor out 8 over 27. 7 cubed is 343 over 8 minus 1. So that would be 8 over 27. LCD is 8. 343 minus 8. So we can cancel out 8. 343 minus 8 is 335 over 27. This is in units. This must be the same as the answer we have acquired earlier. So the distance is vertical earlier and this time we have horizontal element. Next, let's find the length of each of the curve x equal to 1/2 of e to the y plus e to the negative y from 0 to 1. So we need your dx over dy, which is 1/2 e raised to y minus e raised to negative y. So the length of the arc is given by the integral from 0 to 1 square root of 1/2 e to the y minus e to the negative y squared plus 1 dy. So that would be the integral from 0 to 1. We would be having the square root of 1/4. 1/2 squared is 1/4. We will be having e raised to 2y plus e raised to negative 2y minus twice of e to the y e to the negative y plus 1 dy. So that would be the integral from 0 to 1 of, so we have the LCD is 4. We now have e to the 2y. So this would cancel out. So minus 2 plus e to the negative 2y. And then we now have plus 4 dy. So this would be the integral from 0 to 1. And then we have 1 half square root of e to the 2y. Negative 2 plus 4 is positive 2 plus e to the negative 2y dy. So observe that the middle term here is negative and it becomes positive. So instead of having e to the y minus e to the negative y, we now have 1 half integral of e to the y plus e to the negative y squared dy from 0 to 1. So we can cancel out this radical and square. So we have 1 half integral from 0 to 1 of e to the y plus e to the negative y dy. So the integral is 1 half e to the y minus e to the negative y from 0 to 1. So upper limit 1 half e minus e to the negative 1 minus lower limit 1 half of e to the 0 minus e to the 0. So this would cancel out. So the length is 1 half of e minus 1 over e. You may check this using your calculator. Let's check this. Parang may mali. Okay, so this is correct. Now let's have the parametric form. X is equal to t squared, y equal to t squared from x equal to 0 to, from t equal to 0, sorry for this, t equal to 0 to t equal to 5. So, we can have dx over dt equal to 2t and dy over dt also equal to 2t from t equal to 0 to t equal to 5. The formula for the length is the integral from t1 to t2, the square root of dx over dt squared plus dy over dt squared dt. So that's the integral from 0 to 5, square root of 2t squared plus 2t squared dt. So the length is 2t square root of 2. So this is 4t squared plus 4t squared. So that's 8t squared. So 8 is 2 square root of 2. Square root of t squared is t. From 0 to 5 dt. So that would be square root of 2 t squared from 0 to 5. So square root of 2 times 5 squared minus square root of 2 times 0. So the length is 25 square root of 2 units. And finally, let's have this one. So find the length of the curve r is equal to e raised to theta from theta equal to 0 to theta equal to 5. So the length is given by L equal to the integral of the square root of r squared plus dr over d theta squared d theta from theta 1 to theta 2. So we have the integral of the square root of e to the theta squared plus e to the theta squared, because dr over d theta is equal to e raised to theta as well, d theta from 0 to pi. So that would be the integral from 0 to pi square root of e raised to 2 theta, or sorry, that's correct, 2e raised to 2 theta d theta. So that would be the integral from 0 to pi of e raised to theta square root of 2 d theta. So the integral would be square root of 2 e raised to theta from 0 to pi. So we have square root of 2 e raised to pi minus square root of 2 e raised to 0. So we have square root of 2 e raised to pi minus 1 units. So the length of an arc is a straightforward way of solving for the length. It is a direct way of solving for the length by using or by applying the formula. I hope that you have learned something for today. Good day, everyone.